Hello Kagamath! Let's do this! Journey with me as we face, overcome, and befriend the challenges ahead. We can because we are Mathematiisin yan! I am Teacher Andrew, your soulmate. Allow me to guide you in learning the different skills and concepts in Mathematics 9. In the previous episode, one of the skills I taught you was to represent a situation using an equation to be able to determine whether the situation illustrates a quadratic equation. And since we should not bury the skills and concepts we have previously learned, we say, past not dead. Let's read the situation all together and answer the questions that follow. A square piece of cardboard is to be used to form a box without a top by cutting off squares 3 centimeters on a side from each corner and then folding up the sides. The volume of the box must be 300 cubic centimeters. To help us visualize the problem, refer to the graphics on the side as I read the situation once more. The side length of the square piece of cardboard is x centimeters. But after cutting off 3 centimeter by 3 centimeter square from each corner, how long is the portion that remains on each side of the cardboard? The answer is x minus 6 centimeters. And this, of course, is also the side length of the square, which is the base of the box. And then, let's fold up the sides. The box is already labeled with its length and width, which are just the same since its base is a square. But what about the height of the box? The answer is, it's definitely 3 centimeters, which is the side length of the square cut off from the cardboard. The side length of the square base is given by the expression x minus 6, while the height of the box is 3 centimeters. So, we may represent the situation using the equation 300 equals 3 multiplied by the square of the binomial x minus 6. Applying the symmetric property, it can be rewritten as 3 multiplied by the square of the binomial x minus 6 equals 300. Since we have translated the situation into an equation, I think we can answer this question. How long is each side of the square piece of cardboard? Remember that we represented the side length of the cardboard using the variable x. So, to identify the side length, we must solve for x in the equation 3 multiplied by the quantity x minus 6 squared equals 300. And this is our business for today: solving quadratic equations. There are actually 4 methods: extracting square roots, factoring, completing the square, and using the quadratic formula. The equation that we have to solve is of the form a multiplied by the quantity x minus h squared equals k, where a, h, and k are real numbers. If a quadratic equation is of the form a multiplied by the square of x minus h equals k, or of the form ax squared equals k, we solve it by extracting square roots. Alright then, let's solve the equation 3 multiplied by the square of the binomial x minus 6 equals 300. Our target is to achieve the form x minus h quantity squared equals k, which means that the value of a is just 1. So what do? We divide both sides by the value of a, which in this case is 3. Then we simplify. So target achieved. Next step is to extract the square root of both sides. The resulting equation is x minus 6 equals positive or negative 10. We now solve for the value of x using each of the square roots of 100. Hence, the equations x minus 6 equals 10 and x minus 6 equals negative 10. To isolate the variable x, we must eliminate negative 6 on the left side of each equation. We do this by adding 6 to both sides of each equation. So last step is to simplify. So there are two values of x that will make the quadratic equation 3 multiplied by the square of x minus 6 equals 300 true. These are 16 and negative 4. However, we have to reject one of the values of the variable since x represents the side length of the cardboard, which cannot be a negative number. Thus, the accepted answer is 16. The cardboard has a side length of 16 centimeters. Let's have more examples of quadratic equation that can be solved by extracting square roots. So, here is the second one. 5 multiplied by the square of x plus 7 plus 18 equals 1,143. It is of the form a multiplied by the square of x minus h equals k. So our target is to make a equal 1 and eliminate the constant term on the left side. So we subtract 18 from both sides, divide both sides by 5, and then we extract the square root of both sides. Then we solve for x using each of the square roots of 225. So, the roots of the equation are 8 and negative 22. The next examples are equations of the form ax squared equals k, and here is one of them. 4x squared minus 5 equals 0. We have to express this in the form x squared equals k, which means a must be equal to 1, and there should be no constant term on the left side. So, we eliminate the constant term first by adding 5 to both sides. Then we divide both sides by 4. We express the answer in fraction form if the result is not an integer. Then, we extract the square root of both sides. We express the answer in radical form if the result is not an integer. Here, 5 is not a perfect square number. Its highest perfect square factor is just 1. That's why the square root of 5 will just be expressed as square root of 5. 5 will just remain under the radical sign. And that's it. The roots of the equation are square root of 5 over 2 and negative square root of 5 over 2. Last example, 2x squared equals 100. Here we just have to make a equal to 1 by dividing both sides by 2. Then, we can extract square roots and simplify. The greatest perfect square factor of 50 is 25. We can simplify then the radical square root of 50 by expressing 50 as the product of 25 and 2, taking out the square root of 25 and retaining 2 under the radical sign. Hence, the roots of the equation are x equals 5 square root of 2 and x equals negative 5 square root of 2. Now, if the equation is of the form ax squared plus bx equals 0, the method we can use to solve it is factoring. Factoring can also be used in solving quadratic equations of the form ax squared plus bx plus c equals 0 if the trinomial can be expressed as the product of two binomials. Let's have the first example. 2x squared plus 6x equals 0. what is the greatest common monomial factor? Did you say 2x? If you did, you are right. So how do we obtain the other factor? We divide the polynomial by this GCMF. And what is the result if we divide 2x squared plus 6x by 2x? The result is x plus 3. Hence, the equation 2x multiplied by the binomial x plus 3 equals 0. Then we apply the ZPP, and then we solve for x. With the first factor, 2x, equated to 0, we divide both sides by 2 to obtain the value of x, which is 0. With the second factor, x plus 3, equated to 0, we subtract 3 from both sides to obtain the other value of x, which is negative 3. That was mathemagical. The next two examples are of the form ax squared plus bx plus c equals 0. Here is one of them. 2y squared plus 8y minus 10 equals 0. So by inspection, we see that all the terms are divisible by 2. So 2 here is the GCMF. So we have to divide the trinomial by 2. Hence, the factored form, 2 multiplied by the trinomial y squared plus 4y minus 5 equals 0. We can eliminate this GCMF since it's a constant and will not produce any root of the equation. By dividing both sides by 2, we are left with a trinomial y squared plus 4y minus 5 on the left side of the equation, and this we have to factor. The factors of this trinomial must be two binomials, since the leading coefficient is just 1. So we are sure that the first term of each factor is just the square root of y squared, which is y. Now, we have to think of two numbers whose product is negative 5, which is the constant term of the trinomial, and whose sum is 4, the numerical coefficient of the middle term 4y. Have you identified the two numbers? The answer, 5 and negative 1. We position them as the constant terms in the binomial factors. It doesn't matter where we place them, since the first terms of the factors are identical. So the factored form of the trinomial y squared plus 4y minus 5 is the binomial y plus 5 times the binomial y minus 1. Since we already factored the polynomial, we now apply the ZPP and solve for the value of the variable. Last example, 3x squared minus 5x equals 12. First, we express the given in the form ax squared plus bx plus c equals 0. All terms must be on one side, while the other side has to be 0. Alright, so let's subtract 12 from both sides to achieve the said form, the standard form if you remember. Take note that this trinomial is an example of the case where the leading coefficient's absolute value is greater than 1. So, how do we factor such a trinomial? We multiply 3, the leading coefficient, by negative 12, the constant term. Their product is negative 36. So, we have to think of two numbers whose product is negative 36 and whose sum is negative 5, the middle term's coefficient. Have you figured them out? They are negative 9 and 4. So we are going to use these numbers to break down the middle term negative 5x into negative 9x plus 4x or 4x minus 9x. So let's rewrite the trinomial. We will use the factoring by grouping technique. We can let the first two terms be a group while the last two terms form another group. Then, we apply the GCMF in each group. Then we can apply common binomial factoring technique. You would see that both options lead to the same factored form, although the factors are just of different orders, which is not an issue since multiplication is commutative. We can now apply the ZPP and solve for x to determine the roots of the equation. The next method is completing the square. So let me go ahead and share how it is used to solve quadratic equations with this first example. 3x squared plus 12x minus 135 is equal to 0. First step is to isolate the terms with a variable, so we have to eliminate the constant term by adding both sides to 135. Next, we make sure that the leading coefficient is just 1, otherwise, we divide both sides of the equation by the value of the leading coefficient. In this case, we divide both sides by 3. Now is the part where we have to complete the square, meaning we have to add a constant term on the left side to produce a perfect square trinomial, and of course, what we add to the left side, we also add to the right side. So how do we know what to add? We take the coefficient of x, which in this case is 4, then we square its half. The result is what we add to both sides of the equation. Since the polynomial on the left side is already a perfect square trinomial, we can express it as a square of a binomial. This is the form we want to achieve when solving quadratic equations by completing the square. When the equation is already in this form, we can solve the equation just like how we do when we use the method extracting square roots. Let's have another example. X squared plus 2x equals 8. In this equation, the terms with the variable are already isolated. The leading coefficient is already 1. This means that we can go straight to identifying the term to be added to both sides so that the left side contains a perfect square trinomial. So how do we do it? We take the coefficient of x and square its half. Alright, so we add 1 to both sides of the equation. But if you feel like you don't want to deal with variables when solving quadratic equations, the last method is for you. We just have to remember the formula. X is equal to the negative of b plus minus the square root of the expression b squared minus 4ac all over 2a, where x refers to the root of the equation, a, b, and c are the coefficients of the equation. So, we have to write the equation in standard form to be able to correctly identify the coefficients. Here is our first example. X squared plus 5x equals 14. First, we have to write it in standard form. Second, we identify the values of a, b, and c. A, remember, is the leading coefficient or the coefficient of x squared. B is the coefficient of x, and c is the constant term. In the example, a is 1, b is 5, and c is negative 14. Next, we substitute these values in the quadratic formula. Then we evaluate the expression under the radical sign and the one in the denominator. In our example, the expression under the radical sign is simplified into 81, which is a perfect square number, and its principal root is 9. At this point, we must write two equations using both roots of 81, positive and negative. So, upon calculation, the roots obtained are 2 and negative 7. Another example, negative 3x minus 27 plus 2x squared equals 0. We just have to arrange the terms in descending powers to write the equation in standard form. Then we identify the values of a, b, and c. Let's substitute these values in the quadratic formula. Next, we evaluate each term in the numerator and the one in the denominator. 225 is a perfect square number. Its principal root is 15. We write two equations using the two roots of 225 and then we solve for x. If the value of x is not an integer, we express it as a fraction in simplest form. So, the roots are 9 over 2 and negative 3. And that has been a learning-packed discussion. Let's do a review by answering this activity called The Root Shall Set You Free. Use the method of your choice in solving each quadratic equation. Item number 1, 2w squared equals 56 minus 6w. Let's do this. Alright, freeze that hand right there. Let me show you how I used factoring to solve this equation. 5x squared minus 3x minus 2 equals 0. Kagamath, let's do this. And time is up. Did you use the quadratic formula? Because I did. See my solution. And that's it, Kagamath. I hope today's episode has been very fruitful and very helpful. This is your Solvemate, Teacher Andrew. But before we go off air, let me share another motto I hold on to as a mathematics teacher and learner at the same time. Math is not mental abuse to humans. It never was and will never be. See you again next time as we face, overcome, and befriend the challenges. We can because we are Mathemati Isinian.